September 19, 1943. Brest, France. The captured Liberty ship SS James Bowie sat in dry dock number 3, her American registry still visible beneath hastily painted Kriegsmarine identification markings. Officers from the German Naval Construction Office gathered on the pier, briefcases in hand, faces betraying an emotion unfamiliar to men who had spent the war building U-boats and surface raiders at unprecedented speed. Preparing and narrating this type of story took us long efforts and hard work, so if you are enjoying the story, please consider subscribing to our channel. Not fear, not anger, something closer to professional humiliation. This single American cargo vessel, captured intact during a failed convoy operation in the Bay of Biscay, would trigger a crisis within German naval engineering circles that would expose truths they had refused to acknowledge about American industrial capability. The mathematics of maritime construction were about to be rewritten, not through superior design or technological innovation, but through something the Germans had dismissed as impossible: mass production at a scale and speed that made their own shipbuilding achievements look like artisan craftsmanship. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The Liberty ship bore construction number 1247, built by Bethlehem Fairfield Shipyards in Baltimore, Maryland, and launched just 42 days after her keel was laid. Serial documentation captured with the vessel indicated she was one of 2,700 Liberty ships either completed or under construction as of August 1943. Personnel from Kriegsmarine Intelligence had compiled fragmentary reports about American shipbuilding rates throughout 1942 and 43. But seeing the physical evidence made those statistics real in ways that intelligence summaries never could. The James Bowie represented industrial production methods Germany could not replicate, built using welding techniques Germany had avoided. Assembled from prefabricated sections, Germany lacked the infrastructure to manufacture. Constructed in a timeline Germany considered technically impossible for a vessel of 10,000 tons displacement. As German engineers climbed the gangway to begin their inspection, they carried measuring instruments, cameras, and notebooks. What they would document over the following weeks would force them to confront uncomfortable truths about German industrial limitations and American capabilities that exceeded every assumption their planners had made about enemy production. Capacity. The German Navy had entered World War II with confidence in their shipbuilding infrastructure. The yards at Kiel, Hamburg, Bremen, and Wilhelmshaven represented centuries of maritime engineering excellence. German U-boats were marvels of precision manufacturing, complex weapons systems, built to exacting tolerances by skilled craftsmen who had learned their trades through years of apprenticeship in one of Europe's most respected industrial traditions. Germany launched U-boats at rates that seemed impressive by European standards. Between 1940 and 1943, German yards produced approximately 700 U-boats, a construction program that strained industrial capacity and consumed enormous resources. Admiral Karl Dönitz, commander of the U-boat force, had pleaded repeatedly for 300 operational boats to dominate Atlantic convoy routes and strangle British supply lines. He never achieved that number. Peak U-boat strength reached 430 boats in April 1943, with roughly half operationally available at any moment. German surface ship construction had essentially halted after 1940. The battleship Tirpitz, launched in April 1939, required over 2 years to complete. The aircraft carrier Graf Zeppelin, laid down in December 1936, remained unfinished through the entire war despite years of sporadic construction work. Heavy cruiser Seydlitz, converted to an aircraft carrier in 1942, never reached completion. These failures reflected not lack of engineering knowledge but fundamental industrial limitations. Germany lacked the raw material supplies, the industrial infrastructure, and the workforce to simultaneously build U-boats, surface vessels, and merchant shipping while fighting wars on multiple fronts. The Kriegsmarine had convinced itself that quality would overcome quantity, that superior U-boat technology and tactical innovation would defeat Allied convoy systems, despite numerical disadvantages. The appearance of Liberty ships in Atlantic convoys during 1942 had challenged that assumption, with disturbing evidence that America possessed industrial capacity Germany could not match. Initial intelligence reports about American shipbuilding had been dismissed as propaganda or estimation errors. German naval analysts calculated that traditional shipbuilding methods required 6 to 8 months per merchant vessel. Reports claiming American yards were launching ships in weeks seemed impossible. Obvious exaggerations meant to boost Allied morale or deceive German intelligence about actual production rates. The James Bowie, sitting in Brest dry dock with her construction timeline documented in captured records, proved the reports were conservative if anything. She had been built in 42 days, not 42 weeks, 42 days from keel laying to launch, another 14 days for fitting out and sea trials. Total time from start to operational delivery, 56 days. This timeline violated every assumption German naval architects held about ship construction requirements. The inspection began on September 21st with teams of specialists from multiple technical branches. Naval architects measured every structural dimension, documented plate thicknesses, and recorded frame spacing with precision instruments. Welding specialists examined seam quality, photographed weld profiles, and collected samples for metallurgical analysis. Marine engineers inspected the engine room, documenting the triple expansion steam engine and auxiliary systems. Structural specialists studied the hull design, looking for weaknesses or shortcuts that might explain the impossible construction speed. The hull structure caught immediate attention. Where German merchant vessels and warships employed riveted construction, laboriously assembled by skilled workers driving thousands of individual rivets through overlapping plates, the Liberty ship was entirely welded. Continuous seams ran hundreds of feet without interruption. Plates joined with penetration welds that eliminated the need for overlapping sections and the weight of tens of thousands of rivets and backing plates. German engineers understood welding theory. They had experimented with welded construction in U-boat pressure hulls and had achieved acceptable results under carefully controlled conditions with highly skilled welders. But they had never attempted all-welded construction for a vessel this large. The technical challenges seemed insurmountable. Welding introduced residual stresses that could cause cracking. Quality control across thousands of feet of welds required inspection procedures Germany had never developed. Training enough welders to acceptable standards would take years that wartime schedules could not accommodate. The Americans had solved these problems, or perhaps more accurately, had accepted different trade-offs than German engineers would have considered acceptable. The Liberty ship welds showed considerable variation in quality. Some seams demonstrated excellent penetration and smooth profiles. Others showed rougher surfaces and irregular bead patterns. German welding specialists, trained to achieve consistent perfection, initially viewed this inconsistency as proof of inferior workmanship. But the welds held. The ship had crossed the Atlantic multiple times before her capture. She had survived North Atlantic storms that had destroyed German merchant vessels of similar size. The rough welds that offended German sensibilities had proven adequate for their purpose, and adequate welds installed quickly produced more ships than perfect welds that required expert craftsmen working at slower pace. The prefabrication system revealed itself through examination of construction details. Unlike German ships built from individual plates assembled piece by piece on the building ways, the Liberty ship showed evidence of modular construction. Large hull sections had been fabricated elsewhere, then lifted and positioned as complete assemblies. Frame sections showed identical dimensions and spacing that suggested mass production in dedicated facilities. Deck sections appeared to have been constructed as complete units, then welded into place. This approach required infrastructure Germany lacked: dedicated fabrication shops capable of producing standardized sections, heavy lifting equipment to position multi-ton assemblies, precise dimensional control to ensure sections built in different locations would fit together during final assembly, workforce coordination to have all sections ready simultaneously rather than sequentially. The entire system demanded planning and industrial organization at scales German shipyards had never attempted. The engine installation provided another revelation. The triple expansion steam engine, an older technology that American yards could produce in quantity, sat on mounting foundations that showed evidence of pre-positioning. The engine hadn't been laboriously fitted and aligned after hull construction. It had been installed as the hull took shape, with structure built around the machinery, rather than machinery fitted into completed structure. This reversed sequence allowed simultaneous work on multiple ship systems, collapsing the traditional timeline where hull construction preceded machinery installation. German marine engineers recognized this approach from commercial practice, but had never applied it to wartime construction. The method required exact dimensional control and absolute confidence that the hull would be built precisely to design specifications. German practice, which allowed craftsmen discretion to adjust details during construction, couldn't accommodate this approach. The Liberty ship demanded that every component be built exactly to specification because there was no time for field adjustments or custom fitting. By late September, the inspection teams had accumulated enough data to produce preliminary reports for transmission to Berlin. These documents, classified as secret and distributed only to senior naval officers and armaments ministry officials, contained observations that challenged fundamental assumptions about comparative industrial capability. The Liberty ship represented production methods Germany fundamentally could not replicate under wartime conditions. All welded construction at this scale exceeded German welding training capacity and quality control capabilities. Prefabrication required dedicated infrastructure that would take years to build while consuming resources needed for U-boat production. Modular assembly demanded workforce sizes and skill distributions. Germany could not mobilize while simultaneously maintaining land warfare industrial requirements. Most troubling of all, the captured documentation indicated the James Bowie was not exceptional. She was typical. One of hundreds of Liberty ships already operational, and one of thousands planned or under construction. American shipyards were producing cargo vessels faster than U-boats could sink them, a rate that made the entire U-boat strategy questionable if American construction could outpace German destruction indefinitely. October brought additional captured vessels and more disturbing evidence. The Liberty ship SS Nathaniel Bacon, seized in damaged condition after an air attack near Bordeaux, revealed design features that addressed problems German engineers were still trying to solve. Her cargo holds included permanent lighting systems, steam-powered winches for cargo handling, and ventilation systems that prevented condensation damage. These features, expensive additions that German merchant vessels omitted to save cost and construction time, were apparently standard on American mass-produced ships. The welding quality on the Bacon showed the same inconsistency observed on the James Bowie, but also showed something more significant: evidence of repair welds. Sections where original welds had cracked and been repaired at sea or in port. The repairs were crude by German standards, obviously made by personnel with minimal training using basic equipment. Yet, they held. The ship had continued operations rather than requiring return to a major shipyard for specialist attention. This repairability reflected design philosophy differences that explained much about American versus German approaches to maritime construction. Liberty ships were designed assuming that ordinary merchant seamen with basic training could perform field repairs using standard welding equipment. German vessels assumed that damage requiring welding repair would necessitate shipyard attention from certified welders with specialized training. The American approach accepted that repairs might be crude but prioritized keeping vessels operational. The German approach demanded quality but resulted in vessels remaining in port, awaiting proper repair facilities. Intelligence reports from U-boat commanders operating in the Atlantic reinforced what the inspection teams had documented. Sinking reports through 1942 and 1943 showed steadily increasing numbers of American merchant vessels in convoys. Where early war convoys might include a handful of American ships among British and Allied vessels, by mid-1943 convoys frequently consisted primarily of Liberty ships with British vessels becoming minorities. The production rate exceeded even optimistic U-boat successes. In 1943, U-boats achieved their highest tonnage sunk, but Allied merchant tonnage increased despite losses. For every 2 ships the U-boats sent to the bottom, American yards launched 3 replacements. The mathematics were unsustainable from the German perspective. Even perfect U-boat operations could not win a war of attrition against industrial production operating at these scales. November 1943 brought expanded analysis as Kriegsmarine leadership demanded comprehensive assessments of American maritime production capability. The Naval Construction Office produced detailed reports comparing German and American shipbuilding capacity, methodologies, and projected output through 1944 and 45. The comparison was devastating. German merchant ship production in 1943 totaled approximately 250,000 tons, barely replacing losses to Allied air raids and mine damage. American production in the same period exceeded 7 million tons, 28 times German output. Even accounting for Germany's necessarily greater focus on U-boat production, the disparity revealed industrial capacity differences of extraordinary magnitude. The Liberty ship construction timeline of 42 days represented the key differentiator. German yards required 150 to 180 days to build comparable merchant vessels using traditional riveted construction methods. Even with dedicated resources and priority attention, Germany could not approach the American construction speed using available techniques and infrastructure. Welding remained the fundamental limitation. Germany lacked sufficient trained welders to attempt all welded construction at Liberty ship scales. Training programs required 18 months to produce certified welders to German standards. American welding training, according to captured documentation, required 6 to 12 weeks. The quality difference was obvious in inspection. American welds showed greater variability and rougher appearance, but American training produced 20 welders in the time German programs produced 1, and those 20 welders built more ships than a single perfect craftsman ever could. The prefabrication infrastructure represented another insurmountable barrier. Converting German shipyards to modular construction would require building extensive fabrication facilities, installing heavy lifting equipment, and reorganizing workflow patterns. These investments would disrupt current production for months, while construction continued without interruption at yards maintaining traditional methods. The short-term production loss would be unacceptable given immediate military requirements. Moreover, prefabrication required standardization that German industry resisted. Each major German shipyard maintained slightly different construction practices, dimensional standards, and quality requirements. This variation, traditional in European shipbuilding where each yard protected proprietary methods, prevented the interchangeable component approach that Liberty ship production demanded. American yards built to identical specifications, allowing sections fabricated in Baltimore to fit ships assembled in Portland, Oregon. German yards could not achieve that standardization without central authority overriding centuries of yard independence. By December 1943, the pattern had become undeniable to any objective observer. American maritime production would deliver sufficient tonnage to support Allied operations, regardless of U-boat successes. The strategy of strangling British supply lines through merchant shipping interdiction had failed not through lack of U-boat capability, but through underestimation of American industrial capacity to replace losses faster than Germany could inflict them. Admiral Dönitz received reports showing that convoy protection improvements, particularly increased air cover and escort destroyer numbers, were making U-boat operations increasingly dangerous with mounting losses. But even if U-boat effectiveness could be restored to early war levels, the fundamental arithmetic remained unfavorable. America could build Liberty ships faster than Germany could build U-boats to sink them, and each Liberty ship carried 10,000 tons of cargo that sustained Allied fighting capability. The psychological impact on German naval leadership emerged in strategic discussions through late 1943 and early 1944. Confidence in ultimate victory, always strained by the disaster at Stalingrad and defeats in North Africa, eroded further as the implications of American production capacity became clear. Germany was fighting enemies who could replace losses indefinitely, while German losses were increasingly irreplaceable. The Liberty ship represented more than efficient maritime construction. It symbolized industrial warfare waged at scales Germany could not match. Every captured vessel documented American capacity to mobilize resources, organize workforce, and execute production programs that exceeded German capabilities by factors that made traditional military excellence irrelevant. U-boats might be superior submarines built to higher standards than Allied destroyer escorts. German merchant vessels might demonstrate superior craftsmanship compared to hastily welded Liberty ships. None of it mattered if America could build 10 ships for every one Germany produced and could replace losses faster than combat could inflict them. Quality could not overcome quantity at these differentials, and German recognition of that reality marked a turning point in naval strategic thinking. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The detailed technical examination at Brest continued through winter 1943 and into early 1944, expanding beyond simple measurements to systematic analysis of every construction methodology that enabled the impossible 42-day timeline. German engineers, trained in precision manufacturing traditions, struggled to reconcile what they observed with their understanding of proper shipbuilding practice. The hull plate thickness measurements revealed another American departure from German standards. Liberty ships used consistently thinner plates than comparable German vessels, relying on frame spacing and structural design rather than material thickness to achieve required strength. German naval architects had always emphasized substantial plate thickness as primary defense against hull failure, accepting the weight penalty and increased material consumption. The American approach calculated minimum required thickness for design loads, then added modest safety margins rather than the generous factors German practice demanded. A Liberty ship's main deck plating measured approximately 3/8 of an inch, where equivalent German merchant vessels employed half-inch plate. This seemingly minor difference, multiplied across thousands of square feet of hull surface, represented tons of steel saved per vessel and hours of welding time eliminated. German structural engineers initially viewed the thinner plates as evidence of inadequate design, proof that American ships sacrificed safety for speed. But stress calculations performed by the Naval Construction Office's technical staff revealed that the American structural arrangement, with its carefully calculated frame spacing and continuous welded construction, achieved equivalent strength to heavier German designs. The Americans had optimized their structure through mathematical analysis rather than conservative overbuilding. This optimization required engineering capabilities Germany possessed theoretically, but had never systematically applied to merchant vessel design. The calculations demanded understanding of stress distribution in welded versus riveted structures, material properties across temperature ranges, and fatigue characteristics under cyclical loading. American naval architects, drawing on decades of commercial shipbuilding experience and access to advanced metallurgical research, had developed design standards that extracted maximum performance from minimum material. Germany's shipbuilding tradition, rooted in craft excellence and conservative safety factors, had never emphasized this optimization approach. German designs worked reliably but used more material and required longer construction times than mathematically minimum solutions would demand. In peacetime commercial competition, this conservatism meant higher costs but greater durability. In wartime production races, it meant Germany built fewer ships from equivalent resources. The machinery spaces revealed further American innovations in installation methodology. The main engine, boiler, and auxiliary systems showed evidence of pre-testing before installation. Components had been assembled, operated, and verified in factory conditions, then disassembled for shipment and reinstalled in the vessel. This approach ensured that machinery worked correctly before hull construction was complete, eliminating the traditional commissioning period where newly installed systems were debugged after launch. German practice installed machinery into completed hulls, then spent weeks troubleshooting systems and training crews during commissioning. The Liberty ship's pre-tested components reduced commissioning to days rather than weeks, another timeline compression that seemed impossibly risky to German engineers but proved effective in practice. American industrial capacity allowed this approach because factories could test assemblies before delivery. German shipyards, receiving components from multiple suppliers without pre-integration, couldn't verify system compatibility until installation. The electrical systems demonstrated similar pre-planning. Wiring harnesses were prefabricated to exact lengths with terminations installed before routing through the vessel. German ships used field-measured and custom-cut wiring, with electricians measuring runs, cutting cable, installing terminations, and routing circuits individually. The prefabricated approach required precise documentation showing every wire run, but eliminated field measurement and reduced installation time dramatically. Examining the ship's construction documentation, captured intact in the captain's safe, revealed the organizational systems supporting the physical construction methods. The Liberty ship carried complete construction drawings, welding procedure specifications, quality control checklists, and inspection records. This documentation level exceeded German merchant vessel standards, providing permanent records of every construction decision and verification test. The welding procedures particularly impressed German specialists. Each weld-type hull plate joints, frame connections, deck seams, had specific written procedures defining technique, electrode selection, preheat requirements, and inspection criteria. Welders received numbered procedure cards showing exact sequences for each structural section. Supervisors used checklists to verify completion before sections moved to the next construction stage. This systematization made construction quality independent of individual craftsman's skill. A mediocre welder following documented procedures produced acceptable work. A skilled welder could work faster but achieved the same structural integrity. German welding, relying on certified craftsmen trained through years of apprenticeship, produced superior individual welds but couldn't scale to Liberty ship production rates because Germany lacked sufficient master welders. The documentation also revealed cost accounting that shocked German analysts. The James Bowie's construction records indicated total cost of approximately $1.7 million, equivalent to about 7 million Reichsmarks at official exchange rates. German merchant vessels of comparable size cost 12 to 15 million Reichsmarks to build. The Americans were constructing ships for roughly half the cost of equivalent German vessels, even before considering the compressed timeline. This cost efficiency derived partly from welding versus riveting. Welded construction used less material and required fewer labor hours. But more fundamentally, it reflected industrial organization that German shipyards couldn't replicate. The American yards achieved economies of scale through standardization. Every Liberty ship was identical. Every component was interchangeable. Production tooling and fixtures were amortized across thousands of vessels rather than customized for individual ships. German merchant vessels, even those nominally built to the same design, varied between shipyards and even between ships from the same yard. Each vessel was a semi-custom product, built by craftsmen who adapted designs to available materials and local practices. This flexibility allowed Germany to build ships despite material shortages and changing specifications, but prevented the standardization that enabled American production efficiency. January 1944 brought reports from additional captured Liberty ships as the inspection program expanded beyond Brest to include vessels seized in Norway, Italy, and the Baltic. Each examination reinforced the same fundamental conclusions about American industrial methods, while adding details about production variations and design evolution. The Liberty ship SS John Straub, captured damaged off Norway after a torpedo hit, revealed design responses to earlier operational problems. Her hull incorporated additional structural reinforcing around cargo hatches and doubled framing at stress concentration points. These modifications, implemented across the entire production run based on early service experience, demonstrated American capacity to rapidly incorporate design improvements across distributed shipyards. German shipbuilding, with its craft-based approach and yard independence, struggled to implement design changes uniformly. Modifications at one yard might take months to propagate to other facilities. The Americans, working from centralized design standards and detailed documentation, could issue engineering changes that appeared in ships under construction at 18 different yards within weeks. The captured documentation from the Straub included damage reports from earlier service, showing the vessel had survived near-miss bombing, heavy weather damage, and minor collision before the torpedo hit that led to her capture. Each incident had been documented with photographs, repair descriptions, and lessons learned. This systematic approach to operational feedback informed continuous design improvement in ways German naval construction never systematized. German ships that survived damage and returned to service rarely generated formal documentation of repairs or lessons for future construction. Knowledge remained with individual yard workers or ship crews, never systematically captured for distribution. The Americans treated every casualty as a learning opportunity, documenting failures and successes in reports that influenced ongoing production. The welding quality on the Straub showed noticeable improvement over earlier captured vessels, evidence that American welder training programs were producing progressively better results as experience accumulated. Early Liberty ships had shown considerable variation in weld quality between different yard workers. Later vessels demonstrated more consistency, suggesting that training programs were identifying and teaching best practices across the workforce. This improvement trajectory contradicted German assumptions about welding skill development. German theory held that welding expertise required years to develop through apprenticeship and practice. American experience proved that focused training programs, detailed procedures, and systematic quality control could produce adequate results in months. The definition of adequate was key. American welds didn't match German craft standards but exceeded minimum requirements for structural integrity, which was sufficient for the application. February 1944 brought the most disturbing intelligence yet. Reports from neutral sources indicated that American shipyards were reducing Liberty ship construction times even further. The record-setting yards in California were now launching vessels in less than 30 days from keel laying. Some ships were being completed in under 2 weeks, though these sprint builds were publicity exercises rather than sustainable production rates. Even accounting for propaganda inflation, the evidence suggested American yards were continuing to optimize processes and reduce timelines, while Germany's shipbuilding capacity degraded under Allied bombing and resource shortages. The trajectory was clear. America's industrial capability was accelerating while Germany's declined, a divergence that made ultimate victory mathematically impossible, regardless of tactical successes. The German Naval Construction Office produced a comprehensive assessment in March 1944, synthesizing findings from all captured Liberty ships and comparing American versus German maritime production capabilities. The report, circulated at the highest levels of Kriegsmarine leadership, represented the most thorough analysis yet of the industrial disparity that doomed German naval strategy. The assessment documented that American shipyards had achieved production rates approximately 4 times faster than German yards for equivalent tonnage. This advantage derived from multiple systematic differences. All welded construction reduced material requirements by 15% and labor hours by 30% compared to riveted assembly. Prefabrication and modular construction compressed timelines by allowing parallel work on multiple sections simultaneously. Pre-tested machinery reduced commissioning time from weeks to days. Standardized designs allowed tooling and training investments to be amortized across thousands of vessels. Most significantly, American workforce organization fundamentally differed from German practice. Liberty ship construction employed semi-skilled workers following detailed procedures rather than relying on craftsmen exercising independent judgment. This approach, borrowed from automotive mass production, allowed rapid workforce expansion without lengthy training programs. American shipyards had grown from employing roughly 70,000 workers in 1940 to over 700,000 by 1943, a tenfold increase impossible under German apprenticeship-based training systems. The report concluded that Germany could not replicate American construction methods without fundamental industrial restructuring that would require years to implement and would disrupt current production during transition. Even if such restructuring were attempted, Germany lacked sufficient raw material supplies, particularly steel plate and welding electrodes, to sustain Liberty ship production rates. American steel production in 1943 exceeded 88 million tons. German production reached approximately 30 million tons, less than one-third American output, and much of that was consumed by land. Warfare requirements. The mathematics were presented starkly. America would produce approximately 19 million tons of merchant shipping in 1944. Germany would produce perhaps 300,000 tons if production rates held, despite intensifying Allied bombing. The ratio was 63-1 in America's favor. No conceivable U-boat success could overcome that disparity. Even if U-boats achieved unprecedented efficiency and sank 5 million tons of Allied shipping, double their best yearly performance, America alone would still add 14 million tons net capacity, while Germany added negligible tonnage. April 1944 brought practical German attempts to apply lessons learned from Liberty ship examination. The Naval Construction Office issued directives to major shipyards recommending adoption of specific American techniques where German capabilities permitted. These modifications represented acknowledgement that German practice required improvement, even if full Liberty ship methods remained beyond reach. The directive authorized experimental all-welded construction for small merchant vessels under 3,000 tons, sizes where German yards had sufficient trained welders to attempt the approach. Shipyards received specifications for prefabricating small hull sections, though full modular construction remained impractical given lifting equipment limitations. Engineering offices were instructed to review designs for opportunities to reduce plate thickness through improved structural arrangement, though conservative safety factors were retained. The results were modest. Bremen yards completed an experimental welded coaster in 95 days, faster than the typical 120-day timeline for riveted construction, but nowhere near Liberty ship speeds. The welding quality was excellent by German standards, far superior to American work, but required skilled welders in quantities that couldn't be sustained for larger production runs. The vessel used 20% less steel than comparable riveted ships, a meaningful savings, but the welding consumed specialized electrodes already in critically short supply. Other yards reported similar experiences. German industry could implement individual American techniques, but lacked the integrated industrial system that made Liberty ship production possible. Welding without prefabrication, or prefabrication without standardized designs, or standardization without adequate raw materials. Each partial implementation provided marginal improvements but couldn't achieve revolutionary change. The fundamental barrier was infrastructure and workforce scale. Liberty ship production required dedicated fabrication facilities, heavy lifting equipment, inspection systems, and training programs sized for building hundreds of ships simultaneously. Germany's dispersed, craft-oriented shipyards couldn't transform into American-style production facilities while simultaneously maintaining current output of U-boats and naval vessels. Strategic bombing by Allied air forces ensured that even modest improvements remained theoretical. The RAF and U.S. Army Air Forces had identified German shipyards as priority targets by mid-1944. Hamburg, Bremen, and Kiel suffered repeated raids that destroyed facilities, killed workers, and disrupted production schedules. Yards that might have experimented with new construction methods were instead focused on repairing bomb damage and maintaining minimal production. The Liberty ship SS Richard Hovey, captured severely damaged in the Baltic in May 1944, provided final evidence of American industrial dominance through her repair history documentation. The vessel had suffered torpedo damage in January 1944 that would have been fatal to most ships. A hit amidships had flooded 2 cargo holds and caused significant structural damage, including a cracked keel. The Hovey had been towed to a British repair facility where welders cut out damaged sections and installed replacement structure in 14 days. The ship returned to service with full cargo capacity restored. Captured British repair documentation showed that replacement hull sections had been fabricated in American yards, shipped to Britain as standardized spare parts, and installed using the same modular approach employed during original construction. This repairability represented another American advantage German engineers hadn't fully appreciated. Liberty ships could be battle-damaged, rapidly repaired using standardized replacement sections, and returned to service in weeks. German merchant vessels suffering comparable damage typically required months in shipyard for custom repairs fabricated to match original construction. The time difference meant American ships spent more of their service lives operational rather than under repair. The standardization that enabled rapid repair also simplified crew training and reduced operational costs. Liberty ship engine rooms were identical regardless of which yard built the vessel. Merchant seamen could transfer between ships without retraining. Spare parts were interchangeable across the entire fleet. Shore support facilities could stock standardized components rather than vessel-specific parts. German merchant fleet management, by contrast, required tracking individual ship variations, stocking custom spare parts for different vessel types, and ensuring crews had specific training for their assigned ships. This complexity, manageable in peacetime, became overwhelming under wartime conditions, with ships lost, crews dispersed, and shore facilities destroyed by bombing. June 19, 1944 brought the Allied invasion of Normandy, and with it the most dramatic demonstration yet of American industrial capacity. The invasion fleet included hundreds of Liberty ships serving as cargo vessels, troop transports, and supply ships. Over 70 Liberty ships were deliberately sunk as breakwaters to create artificial harbours off the invasion beaches, their hulls forming foundations for the Mulberry Harbour facilities. The casual expenditure of 70 merchant vessels, 10,000-ton cargo ships, each to create temporary infrastructure, stunned German observers. Germany's entire merchant fleet in mid-1944 totaled approximately 400 vessels. The Americans had casually sacrificed the equivalent of nearly 20% of Germany's total merchant capacity for a single temporary construction project, and this sacrifice barely registered against their total production capacity. Kriegsmarine intelligence calculated that those 70 scuttled Liberty ships represented approximately 6 weeks of American production. Germany would require over 2 years to build equivalent tonnage at current production rates, and those rates were declining under sustained Allied bombing. The demonstration made concrete what statistics had shown abstractly. America possessed industrial capacity that made German maritime efforts irrelevant by comparison. The Normandy invasion also demonstrated Liberty ship operational capabilities under sustained combat conditions. Vessels shuttled between England and France under air attack, mine threat, and occasional E-boat raids. Ships were hit, damaged, returned to British ports for rapid repair, and back in service within days or weeks. The cycle continued throughout summer 1944, with Liberty ships maintaining supply flows that enabled Allied armies to advance across France. German naval forces could do nothing to meaningfully interdict this supply chain. U-boats operating in the English Channel suffered catastrophic losses to air patrols and escort forces. Surface raiders couldn't penetrate Allied control of coastal waters. Even successful attacks that sank individual Liberty ships were immediately replaced by vessels arriving from American yards, faster than combat could eliminate them. By autumn 1944, German naval leadership privately acknowledged that the Battle of the Atlantic had been lost not through tactical failure, but through industrial defeat. Admiral Dönitz continued deploying U-boats and optimistically reporting that new technologies, snorkel systems, improved torpedoes, enhanced detection equipment would restore submarine effectiveness. But internal assessments recognized these improvements as marginal refinements that couldn't overcome fundamental arithmetic. America's maritime production had effectively ended German capacity to wage naval warfare through attrition. Every U-boat lost was irreplaceable given declining production rates and dwindling crew training capacity. Every Liberty ship sunk was replaced within weeks by multiple new vessels. The exchange ratio that might have been sustainable in 1941 or 42 had become impossibly unfavorable by 1944. The broader implications of Liberty ship production extended beyond maritime warfare to fundamental understanding of industrial capacity as decisive factor in modern conflict. German military planning had traditionally emphasized tactical excellence, superior equipment quality, and operational skill as determinants of victory. The Liberty Ship program demonstrated that industrial volume could overwhelm tactical advantages if the disparity was sufficiently large. Germany had entered World War II with confidence that technical superiority in key weapons systems would compensate for smaller industrial base relative to potential enemies. Panzer tanks outmatched Allied armour in 1940. The Luftwaffe dominated European skies. U-boats terrorized Atlantic shipping. These advantages were real but temporary, dependent on enemies lacking time to mobilize their superior industrial potential. By 1944, that mobilization was complete. America produced more military equipment of every category than Germany could match. Liberty ships represented just one element of this dominance, but they exemplified the systematic American approach to warfare: identify requirements, design for mass production, organize industrial resources efficiently, execute at scales that overwhelmed enemy responses. The German examination of captured Liberty ships had revealed all these truths by mid-1944. Naval engineers understood exactly how Americans achieved their production rates and recognized that Germany couldn't replicate those methods under wartime conditions. Strategic planners acknowledged that maritime attrition warfare was mathematically unwinnable against enemy industrial capacity. Political leadership received accurate assessments of the disparity. None of this knowledge changed outcomes. Understanding industrial inferiority and correcting it were entirely different challenges. Germany lacked the resources, infrastructure, and time to restructure its shipbuilding industry along American lines. Even if such restructuring had been possible, raw material shortages and Allied bombing would have prevented achieving comparable production volumes. The Liberty ship program succeeded not because Americans possessed secret technologies or superior engineering knowledge. German naval architects understood welding, prefabrication, and modular construction as well as their American counterparts. The difference was systematic application of industrial methods developed over decades in American commercial manufacturing, particularly automotive production. American engineers trained in mass production understood how to design for manufacturing efficiency rather than theoretical performance optimization. American workers trained in assembly line methods could execute detailed procedures without requiring craftsman-level skills. American industrial managers had decades of experience organizing complex production involving thousands of workers, multiple facilities, and distributed supply chains. Germany possessed none of this institutional knowledge at comparable scale. German industry excelled at precision manufacturing for sophisticated products made in limited quantities. German craftsmen produced excellent individual items. German engineers designed technically impressive equipment. None of these strengths translated to mass production of standardized items at American production volumes. The post-war period brought full recognition of lessons that captured Liberty ships had illustrated. When West Germany reconstituted its merchant marine in the 1950s, naval architects consciously adopted American construction methods that had been studied during the war. The new German shipbuilding emphasized welded construction, prefabrication, modular assembly, and standardized designs, all techniques that Liberty ship examination had revealed as essential for efficient modern shipbuilding. The Federal Republic's first major merchant vessels, launched in 1952 and 53, incorporated these American approaches. German yards invested in prefabrication facilities, heavy lifting equipment, and worker training programs modeled on wartime American practice. The traditional craft-based approach gave way to industrial methods that prioritized efficiency and production volume over individual vessel customization. This transformation produced immediate results. West German yards achieved construction timelines comparable to international competitors and captured significant market share in global shipbuilding through the 1960s and 70s. The industry that had failed to match American production during the war successfully adopted those methods in peacetime, becoming one of the world's leading maritime construction centers. The Liberty ship examination had been more than intelligence gathering. It represented a comprehensive education in modern industrial practice that influenced German engineering thinking far beyond shipbuilding. The principles of designing for manufacturing, standardization for efficiency, and systematic quality control, rather than craft excellence, became embedded in German industrial culture. Companies like Volkswagen, BMW, and Mercedes-Benz rebuilt their automotive industries after the war, using principles that resembled American mass production more than pre-war German craft traditions. These companies achieved global success by combining German engineering rigor with American production efficiency, creating a hybrid approach that delivered quality at volume. The Liberty ship itself became an enduring symbol of industrial warfare's decisive nature. In conflicts where combatants possessed roughly equivalent industrial capacity, tactical skill and equipment quality determined outcomes. But when industrial disparities reached Liberty ship proportions, one side producing at multiples of the other's capacity, tactical excellence became irrelevant. The side that could build more, faster, and cheaper would eventually overwhelm opponents regardless of individual engagement results. This lesson influenced Cold War military planning as both NATO and Warsaw Pact forces emphasized industrial mobilization capacity and sustainable production rates rather than simply peacetime equipment quality. Nuclear weapons altered this calculation by making total war potentially unsurvivable, but conventional force planning continued to emphasize the industrial lessons that Liberty ships had illustrated. Modern military logistics still reflects Liberty ship principles. American military operations depend on massive sea lift capacity, much of it provided by roll-on, roll-off cargo vessels that descend directly from Liberty ship design philosophy. These ships emphasize standardization, rapid loading, simplified maintenance, and crew interchangeability, all lessons learned from World War II merchant ship operations. The captured Liberty ships examined at Brest, Kiel, and other German facilities represented far more than enemy equipment brought home for technical analysis. They were tangible proof that industrial maturity and production volume determined modern warfare outcomes more certainly than tactical skill or equipment sophistication. German engineers who examined these vessels understood this conclusion by mid-1944, even as their nation continued fighting against increasingly hopeless odds. The Liberty ship didn't win World War II through technical superiority in design or construction quality. It won through industrial superiority expressed as production volume, construction speed, and operational availability. German naval leadership understood this by late 1943 based on systematic examination of captured vessels. They documented their findings thoroughly and reached accurate conclusions about American advantages. But understanding a problem and solving it are fundamentally different challenges. Germany lacked the industrial infrastructure, raw materials, workforce scale, and most critically, the time needed to restructure shipbuilding along American lines while simultaneously fighting losing wars on multiple fronts against enemies with superior resources. The James Bowie, that single Liberty ship captured in the Bay of Biscay and examined exhaustively at Brest through autumn and winter 1943, told the entire story through its construction methods and timeline documentation. Every welded seam proved that mass production techniques could be successfully applied to shipbuilding at unprecedented scales. Every prefabricated section demonstrated that distributed manufacturing could achieve standardization sufficient for complex assembly. Every day saved in the 42-day construction timeline was evidence that industrial organization mattered more than individual craftsman skill. The vessel itself was unremarkable in many ways, just one of 2,700 built. What it represented was devastating to German confidence, proof that Germany had already lost the industrial war even as combat continued, and that American productive capacity could not be matched regardless of German technical sophistication or tactical excellence. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now and don't forget to subscribe.